Hello students, let us start the next method of factorization, factorizing by making use of algebraic identities. Until now, we have seen two methods of factorization. The first one was factorizing by taking the common factor, whereas the second one was factorizing by regrouping the terms. So now let us see the third method, that is factorization or factorizing by algebraic identities. Now you have learned four identities in your previous topic. Yes, which are those? The first identity is a plus b bracket square, which gives me a square plus 2ab plus b square. The second one is a minus b bracket square, which gives me a square minus 2ab plus b square. The third one is x plus a in one bracket and x plus b in another bracket, which gives me x square plus a plus b x plus a into b, whereas the last one is a square minus b square, which gives me a plus b in one bracket and a minus b in another bracket. Okay, so these are the four identities which you have learned. So now we will be factorizing by making use of these identities. As you can see on the left side, the expressions are in the form of multiplication. Okay, let me write it like this so that the left side will be equal. So a plus b, a minus b, which gives me a square minus b square. Okay, so as you can see, the left hand side of all the four identities, they are in the form of multiplication of brackets. So definitely these are the factors for this expression. That is what the definition of factorizing is, the process of finding the factors of the given expression. So if this expression is provided to you, or this or this or this one, so any one of the expression present on the right side, if it is provided to you, then you will be converting it in the form of the left side, because that is what the expressions are, or we can also call them as the factors. So for that, first of all, we will be looking at how we can make use of those identities. Let me write down 2-3 examples, so then we can move forward. The first example is p square plus 8pq plus 16q square. Okay, so this is my first example. The second one is 81x square minus 49y square. Okay, one more, x square plus 5x plus 6. Okay, or we cannot use that because then we have to make use of splitting the middle term. Instead of that, let us take some another example. Okay, instead of this, let us take 4x square minus 12xy plus 9y square. Okay, now I have written 3 examples here and you have to factorize them. Okay, now it is not necessary that in the question they might specify that factorize making use of the algebraic identities. No, the other two methods which we have seen, this one and one more method I will be teaching you. So they might give you the combined questions and then you have to decide by which method you can factorize them. Okay, so for that there are some tricks that you have to follow to understand which method to be applied. Now as you can see, the first term as well as the last term of this algebraic expression, it is a square, isn't it? P square is square of p, whereas 16q square is square of 4q. Okay, whenever the first and last term of the algebraic expression is a square, you have to first of all check if it is applicable to any identity. As you can see, when you are taking a plus b bracket square, the first term is a square, whereas the last term is b square, that is square of a and b. Similarly, even though if you are taking a minus b bracket square, still the first term is a square and the last term is b square. So as you can see, there are three terms present, and out of that three terms, first and last term is a square. So in your question also, if you are getting an expression of that form having three terms and also the first and last term is a square, immediately check whether it could be compared to any identity. Okay, so now let us see these two identities. What is the difference between these two identities? The middle term, sign of the middle term is different. Here it is plus, here it is minus. So let us check here. What is the sign of the middle term? That is plus. So I will be checking with my first identity. A square. So here my value of A will be P. Fine. B square, my value of B is 4Q. Now the center term is 2AB. So let us write down 8 in that form. 2 into, what is the value of A I have got? I have got the value of A as P. And what is the value of B you have got? The value of B you have got is 4Q. Check if the multiplication of this is equal to 8PQ. See, 2 4s are 8 and PQ. So as you can see, I have written the same expression in terms of the expanded form of the algebraic identity. Now, why do you have to write it? Because then only you can say that it is a square of A plus B bracket square. Directly after this step, you cannot write that P plus 4Q bracket square, because how did you come to know that it is applicable to that identity? You have to represent the given expression in the form of the expression present on the right hand side. Then in the next step, I will be saying, now since my value of A is P, whereas my value of B is 4Q, hence I can say it is a square of A plus B bracket square, and here you have to specify the identity. A plus B bracket square is equal to A square plus 2AB plus B square. Okay, I hope you understood what we did. How do we identify? First, check out how many terms are there. If there are three terms, first and last term is a square, or you can say if there are three terms but there are two terms which are square, it is not necessary that the term in the center will be present here itself. In the question, they might give this term on the other side. Okay, so maybe on the third place. So the condition is there should be three terms. Out of that three terms, two terms has to be square, and if there that is the condition applicable, then check for these two identities. Okay, try to represent it on the right hand side or the expanded form of the identities, and if they are similar to that form, then you can replace it with the left hand side. Okay, and that will be the factors. Now as I told you, whenever you are writing factors, the expressions has to be expression should have multiplication sign between them. So P plus 4Q bracket square is nothing but P plus 4Q written two times. So your final step would be writing the same bracket two times. Okay, fine. Let us come to this example. Again, here are three terms. One is square and other one is square. 4x square is square of what? 2x. Whereas 9y square is square of what? 3y square. So it means this is my value of A and this is my value of B. Let us check. Since the middle term is minus, I will be comparing with the minus identity. So minus 2, value of A I have got as 2x, whereas value of B I have got as 3y. Check if the multiplication is equal to 12. 2 2s are 4, 4 3s are 12, and xy, yes. It is having the same value. Hence, in the last step, I can write this identity is actually similar to A minus B bracket square, where my value of A is 2x, where my value of B is 3y. Bracket square, specify the identity here, and since it is square, write the same bracket two times. Okay, so for first two identities, they are more or less this similar. Only the term of the middle, the sign of the middle term is different. So depending upon that, there will be either plus or minus inside the bracket. Now let us come to our next example, that is how to apply the identity here in this case. Okay. Now again you have to compare the identity or the expression with all the identities. For these two identities, what did I say? There should be three terms. Since here there are two terms, so this two identity gets cancelled. Even for this term, three terms are there, so this identity also gets cancelled. So you are left with the final identity. Now how should I know whether it is applicable to this identity? See, it is a square minus b square. It means in your algebraic expression there should be two terms and both the terms has to be square. Okay, there should be two terms, both terms has to be square with a minus sign between them. What is 81 square of? It is square of 9x, whereas 49y square is square of 7y. So it is comparable to a square minus b square. Yes. And how it could be written? It could be written as a plus b in one bracket, whereas a minus b in another bracket. So write it down. 9x plus 7y and 9x minus 7. Okay, this is very easy. Two terms, both terms has to be square with minus sign between them, and then you can say that yes, it is comparable to the given identity a square minus b square. Now let us look at another one, the one identity which is remaining. Okay, now see, for this identity actually we are making use of our next method of factorizing. Okay, here what is there? The middle term is addition of a plus b, whereas the third term is multiplication of a plus b. So this is what is present in our next method. So let me first explain you that method, then we can see how we can solve by the following identities. Okay, so the next method of factorizing is factorizing by splitting the middle term. Factorizing by splitting the middle term. Now by the name you can understand splitting means separating or dividing which term? The middle term. Let us write down one example. Suppose the example is x square plus 7x plus 12. This is an expression given to and you have to factorize it. Now as you can see, the first method by taking common factor, I cannot do that. For regrouping also there should be even number of terms. Here are three terms, so again second method is not applicable. Third method, using the identities. Even though there are three terms, first term is a square but the last term is not a square, so I cannot use the identity also. Only this identity is remaining. Yes, but for that it has to be represented in this form. Okay, so instead of representing in this form, let us try to solve it by the method splitting the middle term. Okay, now which is the middle term? 7x. What we have to do? We have to split it. Split it means, see, 7x could be written as 5x plus 2x also. Okay, or else 7x could also be written as 6x plus 1x, or it could also be written as 3x plus 4x. Okay, so whenever I am splitting, how do I come to know whether I have to write 5x plus 2x, 6x plus 1x, or 3x plus 4x? Yes, that is decided by your third term. The third term of the expression tells you whether you have to take addition or subtraction of which two terms. Okay, now since here the sign of the third term is plus, yes, so sign of third term in case of splitting the middle term, it tells you whether you have to add the two terms or add the two numbers, or whether you have to subtract the two numbers. The sign of the third term, here it is plus, it means whatever splitting I am taking of 7x, that has to be added. If here it would have been minus, then I would have taken subtraction. Okay, we will be looking for that question also. Or let us take x square plus x minus 12. So let us solve them together. Okay, so now here, what is the sign of the third term? Minus. Here, what is the sign of the third term? Plus. This sign tells me here that whatever splitting I am taking of 7x, that has to be added. And this sign of third term here tells me whatever splitting I am taking of 7x, x, that has to be subtracted. Okay, so sign of the third term tells me that two numbers has to be added. Now again, which two numbers then? 5x plus 2x, 6x plus 1x, or 3x plus 4x? It is decided by the number third term. Yes, the multiplication of the two numbers should be equal to the value of the third term. What is 5x plus 2x? Or just 5 plus 2, 5 into 2, it is 10. What is 6 into 1? It is 6. And what is 3 into 4? 12. So as you can see, the multiplication of these two will give, as you can see, the multiplication of these two numbers gives me the value of the third term. Okay, yes, hence I will not be taking 7x to be 5x plus 2x, neither 6x plus 1x, but I will be taking it as 3x into 4x. Why? Because 3 into 4 gives me 12, and also when I add 3 plus 4, I will be getting the 7x. Whatever factors you are taking, they have to be added in such a way that their multiplication, yes, their multiplication is equal to the value of the third term, whereas their addition or subtraction should be equal to the value of the second term. Okay, so I hope you understood what we are doing. First of all, looking at the expression, compare with whatever methods you know. If they are not applicable to any one of the method, then take the third number first of all. Yes, splitting means the middle term has to be split, but it has to be split in what values? It is decided by the third term. Whatever is the multiplication, that is should be equal to the third term. Okay, so which means that 12 has to be splitted into the factors of 12 are 3 and 4, and addition of 3 and 4 is 7. Since the sign of the third term here it is plus, it means I will be adding these two terms. This is a plus sign which tells you what is the sign of the factors you are taking. So now let us write down, which gives me x square plus 3x plus 4x plus 12. Now here solve further by the common factor method from these two factors and these two. From here I will get x common, so x plus 3 is remaining. Here I will get plus 4 common, so x plus 3 is remaining. As you can see, you have got one common bracket. Take that common again. So the two factors are x plus 3 and x plus 4. Okay. Now let us solve the next example. What did I say? The sign of the third term tells you whether you have to go for addition or subtraction. Since the sign here is minus, it means whatever factors I am taking of 12, they have to be subtracted. Okay, so whatever factors you are taking of 12, so minus 12, whatever factors you are taking, that has to be subtracted, and their subtraction should be equal to what? Nothing is present means what is present? 1. Okay, so the subtraction of the factors has to be 1. Same two factors 3 and 4, because their subtraction is 1. So let me write down 3 and 4. Multiplication 3 and 4 gives me 12 and their subtraction gives me 1. Now if I have to subtract them, definitely I have to put two different signs for them, isn't it? Then only they will get subtracted, because here I want their multiplication to be minus 12. So one of the two numbers has to be minus. Now which is that number? What is the subtraction value I want? Whether I want it as plus 1 or whether I want it as minus 1. See, what is the sign of the middle term? It is plus. So which tells me that the subtraction should be plus 1. It means the sign of the greater number has to be positive. The sign of the greater number has to be positive. Okay. See, minus 3 into 4 is minus 12, whereas minus 3 plus 4 is plus 1. Okay. So the rule says sign of the third term tells you whether you have to do addition or subtraction, whereas sign of second term tells you the signs which you will be taking for the factors. In this case, since there was plus and I had to add the two expressions, so definitely I will be taking both factors as plus plus. What if here it was minus? Factors would have been 3 and 4 itself, isn't it? Okay, and again their subtraction has to be minus 7. When will, their addition has to be minus 7. Now when will this happen? When will the addition of 3 and 4 will be minus 7? When instead of taking it as plus 3 and plus 4, I will be taking it as minus 3 and minus 4. Again check their multiplication. What is minus 3 into minus 4? It is plus 12. Okay, and their addition minus 7. Okay, so that means the sign of the third term tells you whether you are be going for addition or subtraction, whereas the sign of the middle term tells you what sign should be given to the factors. Okay, and factors are to be decided by the third term. So here minus 3 plus 4, simplify, x square plus 4x minus 3x minus 12. Again taking common, x is common, so x plus 4. Now here I want x plus 4 in the bracket. It means I have to take minus sign also common, along with minus 3. So x plus 4, which gives me x plus 4 in one bracket and x minus 3 in another bracket. So these are the factors of x square plus x minus 12. Okay, so the steps, first step says look out for the third term, find its factor. The sign of the third term tells you whether the factors has to be added or subtracted, or let me write down here the steps. That will be pretty easy. First step, factors of third term. First of all, second step would be sign of third term tells you whether you will go for addition or subtraction. If it is plus, you will be going for addition. If it is minus, you will be going for subtraction. Third term, yes, the addition or subtraction should be equal to middle term, isn't it? Whatever is the addition or subtraction of the factors, minus 3 minus 4 minus 7, middle term, minus 3 plus 4 plus x, middle term. Okay, so addition or subtraction of the factors should be equal to middle term. And fourth step, sign of middle term tells you whether what sign should be given to factors. Okay, so these are the steps which has to be followed whenever you are making use of splitting the middle term method. Splitting the middle term method and the identity x plus a in one bracket and x plus b in one bracket, they are pretty same. As you can see, the middle term is a plus b, whereas the last term is a into b. That's why I have told you that identity is comparable to that. Okay, now in both the examples I have taken the coefficient of x square as 1. What if I take the coefficient of x square as other than 1? Let us see. Suppose 3x square minus 13x plus 12. In the previous two example, the coefficient of x square was 1. Here the coefficient of x square is 3. Now when there is some number present as the coefficient of x square, is the method same? We have to find factors of 12 and so on. Yes? No. Whenever the coefficient of x square is any number, the factors has to be found of multiplication of these two numbers. Okay, so your factors will be now 3 into 12, that is 12 threes are 36. Because as you can see, the factors of 12 whose addition is 13 are pretty easy. 12 ones are, because 12 plus 1 is 13. So if you didn't multiply, it means you will be getting a wrong answer, though you are getting a factors whose addition is equal to 13. But that is not the right method. If the coefficient of a square is having some value other than 1, you have to multiply it with your third term and you have to find the factors of that. So let us go by our step. Factors of third term. Here third term would be multiplication of a into c, coefficient of x square and third term, which gives me 12 threes are 36. Factors of 36. Sign of the third term tells you whether you have to add or subtract. Now since the sign of the third term is plus, it means I will be adding the two terms. That two terms has to be added. Further, addition or subtraction should be equal to the middle term. Now whatever factors of 36 you are taking, their addition has to be 13. Okay, addition or subtraction should be equal to middle term. Middle term is 13. Here I have to take addition because of this sign. So 36 factors whose addition is 13. 9 fours are, as you can see, 9 plus 4 is 13. Last step, sign of the middle term tells you what sign has to be given to factors. What is the sign of my middle term? It is minus. And since both have to be added, it means the sign of the factors would be minus minus. Then only they will get added, isn't it? If they are opposite sign, they will get subtracted. Okay. So according to the steps, we have moved forward. So now let us split minus 13x, which gives me minus 9x minus 4x plus 12. Taking common, what is common between 3x square minus 9x? It is 3x. Divide 3x square by 3x, x is remaining, minus 9x by 3x gives me 3. Here minus 4 is common, x minus 3. One bracket has to be compulsorily same. So x minus 3 will be my again common. What is remaining then? 3x minus 4. So the factors of 3x square minus 13x plus 12 is x minus 3, 3x minus 4. Okay. So this is the steps which you have to follow. If you follow by these steps, it will be very easy for you to find the factorized form. Okay. So factors of third term, or you can say multiplication of coefficient of x square and third term. Yes, if the coefficient of x square is 1, then you will directly find the factors of third term. But if the coefficient of x square is any number, you have to take the multiplication of coefficient of x square and the third term, and then their factors you will be finding. Okay, so this is what the method is, which is named as factorizing by splitting the middle term. Why? Because we are splitting the middle term in such a way that we could factorize them forward.